is the first one. It's 30 is like that.
No, it's not the first time. Those that have it.
Slight modification.
Have fun. Okay. I'm going to start with this one, the triangle example, because we kind of did one like that yesterday. So the sketch is already drawn out for you. Police car is coming this way. They're going to chase the speeding car. The speeding car is going this way, but they can't cut across. They have to go through the intersection, so you get this distance here between them. That as this car comes down and this car goes, that distance will change, right? So then they give us much information. We set them up yesterday, but we didn't start plugging in yesterday. So that really we're just looking at, are you plugging in an amount or a rate? Plugging in X if it's an amount, or like DXDT. So I'm just going to read through this and kind of label things. So the police car is 0.6 miles north of the intersection. So that tells me Y is 0.6. Y is the vertical distance. There's a point there. It's just really small. Good. Okay. The car is 0.8 miles to the east, so that's going to be X equals 0.8. And then I don't know yet if I'm going to need this or not. I actually think I don't, but just to get the habit of like, let's find all the stuff. Could I find Z? That thing right there, right? So it's going to be 1. But then all of those things are changing. That's just like a 3, 4, 5 triangle. 3, 4, 5, 6, 8, 10. All of those things are changing as time passes. This Y is getting smaller, this X is getting bigger, the Z, I don't know. So we also need to know what is dy dt, what is dx dt. These things are changing also as time passes. So, police determine with the radar gun that the distance between them and the car is increasing at 20. So what am I going to label as 20? The distance between the police car and the speeding car is increasing at 20. That is dz dt. So this is a rate. This is like how much, this is a derivative, it's a rate, it's a representation of change, increasing at 20 miles per hour. So this car is moving 60 miles an hour, moving 60 miles an hour, but keep in mind it's going down in our setup here. So this is negative 60. And then the question is, what's the speed of the car? And that's dx dt, like how fast is X changing. So this is what we're looking for. Questions on any of that? So then we find our equation, like we did yesterday, so I got 3 sides of the right triangle, right? So we put that back in there, so X squared plus Y squared equals Z squared. But I was wrong, we do need the Z. Because I was thinking it was like yesterday, the ladder doesn't change, right? But this distance is changing. So I'll take the derivative, but if you take the derivative of a variable, multiply by d, whatever that variable is, over dt, because all the variables are changing with respect to time. It's nothing fancy for me, it's just plug and chug. Just make sure you're plugging in the right spot, the right numbers. So X is the horizontal distance, which is 0.8. Dx dt is what I'm looking for. There. Y is the vertical distance, which is 0.6. Dy dt too much of an issue here, but I end up like 1.6 dxdt because multiplying those. That's 20. This is negative 72. No, it's 40. 72 plus 40, so this is 112. And whatever 112 divided by 1.6. Then I know. Seven. What's the label on that? Miles per hour. That's a rate, right? That's dxdt. That's a rate. That's miles per hour. It's not even speeding. Although back. True. Yeah, like, there's no red angle in the expressway. And I don't think when this button was written, it didn't used to be so. What's up?
As an expert in this area, that is a fact.
70 speeding? In what zone?
Oh, in this instance, it is.
What's the speed limit in this instance?
Well, probably 55. It's unmarked. I know that's not the highway. Maybe it is the highway. Maybe it's the world record.
That's just the expert.
I thought you were going to tell me you guys pulled up from 70 to 35 or something.
It's worse than that. You think that's bad? Oh, it's worse.
25? It's a big
Speed
deal.
limit.
It's a speed.
The man got pulled over in his bike.
Going what?
And down that road, and
How fast were you going to the park?
Ask him how fast he's going down south.
Yes.
Yes.
90. How many tickets do you have?
Also, as many as how fast.
4?
What was the exact number outside?
Alright, let's go number 1.
Yeah.
Wait, I got a calculus. As time goes to infinity, of max equals j. I made a calculus, bro.
That's true.
He's been working for that for years. Okay, let's go. Let's do the calculus. So this is the same stuff. It's just not like a story book. It's almost easier because they're not making use of the equation. So they're just saying, here's an equation. Find dy dx. They're going to give you enough information to do that. Remember product rule. Most of you, I don't know, half of you, there's not product rule in this one. But about half of you forgot product rule on the implicit differentiation on the gateway. There was one that was like 2xy. And that is a variable times a variable, so you would have to use product rule. I don't know if there's any in this assignment. Or that's a product rule. That's b times h. You have to make sure of that when you do product rule. Okay, well, let's go back to the example. So we're going to take the derivative. Anytime we take the derivative of a variable, we multiply it by d whatever over dt. d2y times dy dt equals 12x cubed times dx dt plus 6 times dx dt. It might look like they didn't give us enough, but they did. It's just in this annoying way. So when I'm going through the first time, like, okay, I don't know why. I'm looking for dy dt. So I've got a problem right away because I don't know what y is, and it's not what I'm supposed to solve for. So I've got two unknowns. I can fix that in a second, but right now we're kind of wondering what goes there. X is 1, dx dt is 2. So like all that's fine, but I need to. I'm trying to find dy dt. I don't know what y is. So the first thing I have to do is find y, so I can plug it in. But that's just using the original equation. If you go up here, x is 1, so y squared equals 3 y squared equals 9. Then we can say y equals 3. Then I can put the 3 in there. It's like a side quest you have to do to get that 3. And then, is it fair if I just say you guys do the algebra? Not first time, yeah. I had heard teachers say, like, or students say, like, and then Mr. Whatever says, just do the algebra. And I'm like, I'm not doing the algebra. But that's in, like, regular physics. Where am I? Okay. Question on 1. Alright, so 2. So now we're back to like you got to set up. They didn't give you a drawing. They didn't give you an equation. You got to set up and figure out what we're supposed to work with. So I see a rectangle. I see width. I see length. I see area. So basically, I'm supposed to be able to find the area of a rectangle. It should use length and width. Fortunately, it does. Area of a rectangle is L times W. I have to take the derivative of that. What do I have to use? I have to use product rule because those are two functions being multiplied together. So the derivative of A is just 1, but then you took the derivative of an A, so multiplied by d dt. The product rule, so the second thing is W times the derivative of the first thing. The derivative of L is dL over dt. 2d1 plus 1d2, so plus the first thing, which is L, times the derivative of the second. And then I'm going to plug in what I can, and sometimes I'll have to do like a side quest, like we did in the previous example, to find a number. Sometimes I don't. That's what they give you. What rate is the area increasing? That's what I'm looking for. So this is telling me we're looking for the rate of area, so d dt. Hopefully I can just plug in over here, but what am I in? So the width is 4. Length is 5, so I can put those in. And then dl dt, the length is increasing at a rate of 3. And the width is increasing at a rate of 2, so dw dt is 2. They could give you this and tell you like the width is 5. Sorry, the length is 5. And the area is 20. And they can do kind of side quest and be like, oh, well, that means the width must be 4. They didn't do it for this one, but you have that situation sometimes. And then we can just like work this out. So that's 22. What would the label on that be? Not centimeters per second. Did you say squared? Yeah, centimeters squared per second. It's squared because it's area. It's per second because it's the rate. Question on any of those 3 examples? I don't think that I need to go through anything else. But, if you guys find that I do, then tell me. Otherwise, go ahead and get to work. And right? Like, this makes more sense. Don't worry about 11. You don't have to do the test prep one. Usually like 4.
nice. I've seen you like walk around town before. My dad like 2 years ago.
Yeah.
And I was looking at it. I was like, I want to take that. I told my mom, we drive up, we can like knock on over and steal it and drive off.
Make sure we're calculating, please.
Alright.
It's like a cycle, right? Hard time to make stop.
Oh yeah, it's I think it's back to sometimes. It's like the side.
Yeah.
We were doing that. I was looking at that.
Wait, I thought it was just two. There's four.
Hard times make good people.
Hard people.
Hard people.
Hard
Dude, stop.
hard
Already
times.
slipped.
Make soft people. Soft people make hard
No,
times.
hard times make hard people.
Hard times make
Hard
good
times
people.
make hard.
Good people.
Hard people make good times.
Dude,
Good times
okay.
make soft
You're
people.
just saying.
Hard times make hard people. Hard people make good times. Good times make soft people. Soft people make hard times.
Yeah.
I thought it was strong.
Why are you so angry?
I don't know.
You're just like mad about it. Stop people, man.
I think it's
Good times.